All right, guys, here we go. The second half. So I've already started this. F of x equals the square root of x. For the parent function, I've noticed that you can't have any negatives in there. Can't have square roots of negatives. So it has to be positives, including 0. So we start with 0. And then I'm going to go 1, 4, 9 just to get the ball rolling, because those are all perfect square roots. 0, 1, 2, 3. I kind of get the idea. 0, 1, 1, and then 1, 2, 3, 4, 2, and then 4, 5, 6, 7, 8, 9, 3. And there's the parent function. All right, so now I'm going to go with the orange marker for this first one. That means flip it. Flip over the x. So that would be right here. And then I got to move it left 1. So left 1 would be right here, and then here comes the grand finale, and it would look something like that. Perfect? No, but it gets the job done. All right, next one. Back to the parent function. We got to have a vertical stretch by 3. So we start 0, 0, 1 turns into 3, because 3 times 1, the y value would be 3. So it goes up to here, and I can kind of just say, all right, it's going to look like that, and that's going to move it down 2. So I take that whole thing, move it down to 1, 2, and then I try to kind of duplicate it. It's got a vertical stretch of 3. That's where it would end. And then we'll go yellow for the grand finale here. So that just means take the parent function, which is pencil, move it left 2, and then down 4. We're going to do this in one move. So we take the pencil one, left 2, ding ding, down 4, 1, 2, 3, 4, and just try to duplicate it. And there it is. I don't think those are crazy difficult. All right. Now we're getting this wackadoodle graph. It could be a little more challenging, but let's see. It says m of x, which is just this, some little funky w, and they're saying, all right, now apply some rules to it. Well, if we take the negative as one piece, we know that that's going to flip over the x. So we're going to start with this. I'll finish it with a color, and then to 2, and then back to here, and then it kind of shoots off this way, kind of sharply. Not perfect. But then we have to double the magnitude, or whatever you want to call it, the amplitude, and vertical stretch. So that's going to come this way faster, and that's -2, so that go to -4. And 2 times 0, and then that's just sharper down. All right, vertical stretch. So now we just need to move the original left 2 down 1. So I'm going to do every point left 2 down 1. Left 2 down 1. That one left 2 down 1. Connect the dots. Left 2 down 1, and that stops right there. Left 2 down 1, there's the peak. This one left 2 down 1. This one left 2 down 1. That's it. Throw some arrows in there. I think we got it. And then we'll go orange, take the original, right 1, up 3. So take the original, right 1, up 3, right 1, up 3, connect the dots. Right 1, up 3, 1, up 3, and then this point, right 1, up 3. There. We've moved it. I don't think you'll have too much of a problem with those. Let me pause this a second. Okay, so this is a question whether or not these functions are odd or even. So the best thing to do is to really get a visual. So we're going to type these into our calculators. I'm showing you the window that you should start with. Maybe we'll have to adjust it, maybe we won't, but I'm going to type it in and show you what's up. All right, so there's the graph. If you're curious about where to find the absolute value, you're just going to go math. I'll show you after we're done, but this is the graph that this spits out. So remember the rules. It is odd if it rotates over the y-axis and then you have the exact same graph, it's even. Wait a minute. Pause. All right. I got to own my mistake. I just in a hurry. The test for odd is not over the y. The test for odd is 180 degree spin over the nail at point 0, 0. The even test is if you go just flip it or reflect over the y-axis, and you get the exact same drawing. So if you look at this, if you flip this over the y, it's a line here. Whoa. If you flip this over the y, that big shiny thing there, it's not going to be the same graph. But if we stick a nail in the origin and then we flip this thing 180, just like this, just like that, we have the exact same graph that we had. So what does that do? It passes the odd test. So this would be odd. All right. So back to the graphing portion. If we want to graph this or plug it in, you got to go to math, and then it's nowhere in here. You got to go to one step over to here to numerical or numbers, and then the absolute value option pops up. So just FYI. So now I'm going to type this in. I'm going to hit pause. Okay, so this one, got ourselves a parabola. We can tell by looking at it. There it is. So if we rotated it over the y-axis, would it be the same drawing? No. If we spun it around the origin 180 degrees, would it be the same drawing? Obviously no. So this is neither. Neither for that one. All right, let's go on to this one. So if you notice this one, even. So the guess is even, but let's not guess, let's check it out. So like we kind of thought, it's even. Why? Because if you reflect it over the y-axis, it's going to be the exact same drawing. So there it is, even. That one's an easier one. All right, let's type this letter D into our calculator and see what it gives us. So on this one, I mean, literally typing it into the calculator might throw you, because if you don't insert parentheses here, it won't read it properly. It might read it as x over 1 plus x squared. You got to make sure it's over the entire thing. So just an FYI, make sure you know how to type it in properly. Now let's hit graph, and hopefully it shows up in our 10 by 10 window. And what the heck is that? All right, well, as you can see, if you flip it over the y-axis, it's definitely not going to be the same graph. So it fails the even test, but the odd one, if we rotated it 180 degrees, notice what it looks like. We flip it 180, it'd be the same graph. So it does pass the odd test. All right, there you go. Okay, don't forget to be on the hunt for a unit circle. That means the radius is 1, and if you don't know that, and they're expecting you to know that, or you don't read it, your answers are going to be all wacky. So, radian measure. First of all, convert the following angles from degrees to radians or radians to degrees. Clearly this is radians, and so I think these are the easiest ones, because all you got to do is pop a 180 in there and reduce. So I'm going to focus on this right here. I know that 12 goes into 181. Oh, come on now. 60, that'd be 15 times. So it'd be 130, wait, 70, that'd be 105 degrees. Struggle bus. All right. I'm going to do the same thing here, but this one's even easier. Pi over 3 is 60, so 10 times 60 is 600 degrees. Done. Let's go to this one. So we've got to go from degrees to radians. Now, what we should be thinking about is 30, 45, 60. Do any of these go into that evenly? And the answer is no. But if I was to check it out, I would go 220 divided by 45. we're going to get a decimal. So it's none of these easier ones. So what we have to do is multiply it. Remember, that's a symbol for degrees. So we're going to go pi radians over 180 degrees. This degree cancel with that degree. So we're going to reduce. Clearly 20 goes into that 11 times. 20 goes into that 9 times. So 11 pi over 9 radians. If you actually multiplied this out, 11 times 3.14 divided by 9, you'd get something else in a decimal form, and that'd be fine too. Negative 15. So we know it's going to be negative, so it's negative 15. I'm going to write the word this time. Over 180 degrees pi radians. Degrees go bye-bye. 5 goes into that. Negative 3 times. 5 goes into that 36 times. Oh, so 15 would have gone into that. So negative 3, negative 1, that'd be negative 12. So we get negative 1 pi over 12. I don't know where that negative came from. Radians. All right, there we go. Now, how can you check that? Check it by going 180 divided by 12, and we better get 15, and we do. So good way to check it. So this says find an angle between 0 and 2 pi that's coterminal. That means they end in the same spot, exact same spot. And this means no negatives, and it also means nothing greater than 360. So there's a lot in here. Draw a picture of an angle in the unit circle. All right, well, first thing we know is that right there is 60. So 13 times 60, going to have to use my calculator for that. No, I'm not. That's 780. All right, so now watch this. 360 and 360 is 720. So this spin is basically 780 minus 720, which is 60. I know this is a mess, I'm sorry. What's 720? Well, if I spun my spinner one time around, 360, another time around, 360, that's 720, and I'd have 60 degrees more to go to land right on top of 780. So this is 780 or 60, and 60 fits in between here. And it doesn't say leave your answer in radians or degrees, so whatever. Let's do this one. So the first thing we're going to do is figure out what this is. Pi over 4 is 45, so it's negative 5 times 45, which is negative 225. So we start right here. We go that far. That's 180. We go another 45, and we stop right there. So that's what this picture is. But they're saying go in a positive direction and end up here. What is it? Well, that would be that plus that. It's 90. Plus 45, which is 135. Same coterminal, ends in the same spot. Find both a positive and negative coterminal angle. So the same sort of stuff, but now they're making you go both ways. So we start with this. I'm going to convert that to degrees. 45 times 3 is 135. So that's the original spin, which is right there. So let me get out a yellow marker. And to go the original spin, I have to go positive 135, and essentially I have to go around another 360. So if I added that together, I would get 495. There's my positive one. Now what's my negative one? Well, that would be starting here and just going that direction. Doing the math, I know this is 90 and I know this is 45. So 90, 90, 45 would be 180 and 45, or negative 225. There's my positive one and my negative one that end right at the same spot as this guy. This is pi over 6, that's 11 times 30, which is 330. Draw my original spin starting here, up, just shy, 30 degrees shy of 360, so that's 330. All right, so I got to find a positive one and a negative one. I think the negative one is pretty easy. That's just down 30. To find the positive one, we got to go all the way here. which is 330, and then keep going a full revolution, so I got to add 360, and that would add up to 690. There we go. Determine the coordinates of where the given angle intersects the unit circle. This is big. Unit circle is finally important. So it says, flip your spinner, which is length 1, 180 degrees, and it stops. Well, if the spinner is length 1, that point right there would be -1, 0. There's your coordinate point of the tip of the spinner. That's what they want. Pi over 6. That's just 30 degrees. So I take my spinner, spin it up 30, and stop. Well, if this is 30 and this is 1, and I connect the dots there, I'm trying to figure out that x and that y, I got to use my rules. That's going to be half, so 0.5 or 1/2, and I got to multiply that by the square root of 3, so I get 1/2 square root of 3. Here's my x value. So that'd be the square root of 3 over 2. My y value is 1/2. This guy, -pi over 4. Well, that means spin it down 45. Spinner's 1, always connect it to the x. Don't forget, guys, my hypotenuse needs to be the longest side, so I have to divide by the square root of 2 to get here and here. Get that square root of 2 out of there. I get the square root of 2 over 2, but it has to be negative, and this one has to be positive. So what's the coordinate point? Square root of 2 over 2, negative square root of 2 over 2. Last but not least, that's 120 because it's 2 times 60. So I get my original spin, 90 and 30. Be careful on this one. Yes, that's 30, but my reference angle's right there. Connect here. This is negative, whoopsie. Almost made that a 1, but I got to remember this is a unit circle, so this is 1 right there. This is 30, so I got to take half of that, which is -1/2 left. Multiply that by the square root of 3, so this is going up, so it's positive square root of 3 over 2. So that coordinate point is -1/2 square root of 3 over 2. There's the coordinate point. Alright, so I'm going to try to finish this in this video, so let's do it. Find the exact value. That means find the fraction. It does not mean type it into your calculator. What that means is you got to draw the spinner. So what is this? Well, that's 2 times 60. Flip your spinner 120 degrees. So we start there. 90 and 30 would take us right about there. Do a good job being halfway accurate. It doesn't say a unit circle, so you can relax. I'm going to call this 1, but it has to be negative. My spinner is 2. This is the square root of 3. What sign? Opposite over my hypotenuse. So that'd be the square root of 3 over 2. Let's go to this one. 7 pi over 4 is 7 times 45, which is 315, which is, spin it all the way here. There's a 45. That's a 45, but I draw my triangle here. I'm going to let that be 1, -1. This is a 45, 45, 90. What's cosine? It's adjacent over hypotenuse. 1 over the square root of 2. And when they're these special triangles, they're going to want you to get that square root out of the denominator. Tangent. Pi over 6 is 30, so 5 times 30 is 150. It's telling you how to draw your triangle. 90 and 60. Leaving us with 30. Draw your triangle. That's a 1, that's a 2, that's a negative square root of 3. Just using traditional values for a 30, 60, 90. What's tangent? It's opposite over adjacent. TOA. 1 over negative square root of 3. So I got to get that out of there. I don't care about the negative. So I get the square root of 3 over 3, and the negative typically stays up top. Here comes a quadrantal. Pi over 2 is 90. 3 times 90 is 270. That would actually go from here and land right here. Don't do it. Stop just shy. And remember, this is my opposite. This is my adjacent, which turns into 0. And that's my spinner or my hypotenuse. These two are the same, but that's negative. So what's sine? That'd be opposite over hypotenuse. They're the same, but they're opposite. This is a negative version of it, so sine would be -1. Now, could you check your calculator, type it in, sine of 270, and see if you got it? Yes. Am I going to be looking for that? Yes. If you have this with no picture, no credit. Sorry. All right, flip your spinner -30, down 30. There it is. So that's my -1. There's my hypotenuse. There's my adjacent side. That's my 30. That's my reference angle. What's cosine? Adjacent over hypotenuse. Almost done. 5 pi over 4 is 5 times 45, which is 225. Spin at 180 plus another 45. Stop. Don't ever go back to the y. Back to the x. There's my 1, there's my 1, there's my square root of 2, because this is a 45, 45, 90. That has to be negative, that has to be negative. Take care of those negatives. What's sine? Opposite over hypotenuse. So -1 over the square root of 2. Get that radical out of the basement. Good parenting 101. And there you go. All right. We're going to make a third video where we get into graphing trig functions. So there you go.